Hi and welcome to Gaffy's Grinds. This is video 7 in our series on atoms, elements and the periodic table. In a previous video, we learned how to draw atoms, including especially how to draw the position of the electrons. This channel is all about practice and retrieval. And retrieval just means that we give ourselves the opportunity to try and remember things that we've done previously. And this strengthens the memory and it makes sure that we remember it. We transfer it to our long-term memory. I always give you the reminder that when I ask you to do things, it's really important to do them. Otherwise, you're not going to learn very much. So I'm going to begin today's lesson by asking you to draw me an atom of calcium. So I want to pause the video now and draw an atom of calcium. Okay, so first of all, the first thing you need to do is show me watching the video if you have drawn an atom of calcium already. The first thing you need to do is find calcium on the periodic table and find out how many electrons it has, calcium. So calcium has the symbol capital C, A, capital C, lowercase a, and the number of electrons it has 20 electrons. 20 electrons. We know this because its atomic number is 20, which means it's got 20 protons, and it's an atom, so it must have the same number of electrons as it does protons because the charges need to balance. So you need to have 20 electrons. So let's start by drawing calcium. So we put our nucleus in the middle, which is we're just going to put the symbol in there. Now we know there's protons and neutrons in there, but we're not going to worry about drawing them for now. We know how to work out exactly how many of each of those there are. We've learned that before, but for now, we're just going to write Ca. We then start to draw our electron shells, or what we call our energy levels. I'm going to begin by drawing the first shell, or the first energy level. And I'm going to put 2 electrons in there because I'm allowed to put 2 in the first shell. I then draw the second shell and I'm allowed to put a maximum of how many in here? Speak your answer to the screen on 3. 1, 2, 3. You should say 8. And I have to fill up this shell before I'm allowed to start filling any more. So I put 8 in here. Altogether now, I've drawn 10 electrons, 8 in the second shell and 2 in the first shell. That's only 10, and I need to make sure that there's 20. So we need to open up a third shell. So I'm allowed to open up the third shell once I've filled the second one. So I can fit a maximum of 8 in here. So if I put 8 more in here, that would get me to 18. So yeah, I'm definitely going to fill this shell. So I can put 8 in here like this, draw them in pairs like this, and that gets me to 18. That's not finished yet because I need 20 electrons. So I'm going to draw a fourth shell, and I'm going to put the last 2 out here. So if you drew that, well done, good job. Now, I'm going to introduce you to a new thing today. When scientists have this shortcut way or a shorter way of writing and figuring out where the electrons are in an atom. And really it works by just making a list, starting from the nucleus and working out, making a list of how many electrons are in each shell. So the list looks like this. So say we take our first shell. This is the first shell that's closest to the nucleus. We say that there are 2 electrons in the first shell. We then put a comma to show that we're separating and we're now talking about the next shell. The second shell, in this case, in calcium's case, has 8 electrons, comma. The third shell has 8 electrons as well. And then the fourth shell, another comma, well, it has 2. So we write 2. What we've done here is we've written something called the electronic configuration. Electronic configuration. So the electronic configuration for calcium would be 2, 8, 8, 2. You try now. I want you to do phosphorus. So I want you to draw an atom of phosphorus, and then I want you to tell me the electronic configuration for phosphorus. Pause the video. Do that now, please. Okay, so phosphorus has 15 electrons. So phosphorus, P, has 15 electrons. Now, if you did not write for 15 electrons for phosphorus, you need to pause the video and redo it now. So draw the atom with 15 electrons. So if you made a mistake and you said maybe If you said 31 electrons, then you looked at the wrong number on phosphorus. Okay. So this is how we would draw it. We would have a capital P, and we would have 2 electrons in the first shell. We would have 8 electrons in the second shell. That gets me to 10. And I would have 5 more because I have to do 15. I'm going to open the third shell now because the second shell is full. And I'm going to do 2, 4, and 1 more, 5 electrons. So for my electronic configuration then, now you don't have to draw these lines, by the way. I'm just drawing them to show you how it works. So after you get the hang of it, you can stop drawing these lines. So the first shell, 2 electrons. The second shell is full, so it's got 8. So 2, 8, good. And lastly, the third shell has 5 in it. So 2, 8, 5. So I sometimes then shorten it to E.C, which is short for electronic configuration. Electronic configuration for phosphorus is 2, 8, 5. Now, you're ready to do some of these for yourself. In the previous lesson, okay, you drew the following atoms. So I had this list where I asked you to draw out each of these atoms. So what I want you to do now is I want you to go back in your copy and find where you drew all of these atoms, nitrogen, oxygen, helium, and so on. You drew the atom for each one, and I want you underneath to write the electronic configuration for each one. So do that now. Pause the video and do that, please. Okay, so you should only be watching if you've done the electronic configurations for all of these atoms. Okay, so what I'm going to the answers are about to come up now. Okay, so here they come. So nitrogen is 2,5, oxygen is 2,6, helium is just 2, and so on. So pause the video now and correct each of these, please. Any of them that are wrong, that you got wrong, just take a closer look and think about why did you get them wrong. Okay, I think it's pretty straightforward. I'm hoping that you managed to do this okay. Okay, all right. So that is the electronic configuration. Now, this here is the periodic table. So how does electronic configuration link to the periodic table? Okay, I'm going to highlight 3 elements here. I'm going to highlight these 3 elements: lithium, sodium, and potassium. These 3 belong to the same column. They're in the same vertical column. What do we call these vertical columns in the periodic table? So speak your answer to the screen now. 1, 2, 3. Okay, we call the vertical columns groups. This here is group 1 in the periodic table. I know that it's group 1 because it's the first vertical column. They all belong to group 1. Now, why are they in the same group? Why are lithium, sodium, and potassium in the same group? So over here, I'm going to write down the question. So what I want you to do is be thinking about the answer to this question. Why are those 3 in the same group? Now, we answered this before. So why are lithium, sodium, and potassium in the same group? I want you to pause the video and speak your answer to the screen. Why are they in the same group? Okay, I'm hoping that you said they have similar properties. What do we mean by similar properties? Well, they are all soft, shiny metals. They are soft, shiny metals. They are gray in color. These are properties and they are all similar. They're not the exact same. So some are softer than others, some are shinier, some are more gray or darker gray, but they are similar properties. But most importantly, they are all highly reactive, extremely reactive. They react really easily when we put them, especially when we put them in water. But even if we leave them out to react with the air, they will really easily react. The next question is why? Why do they share these properties, and especially this one? Why are they all reactive? Why do they all have similar chemical properties? To answer this question, you're going to need to draw them. So what I want you to do is draw me an atom of lithium, sodium, and potassium. So we're going to do lithium, sodium, Na, and potassium, K. I want you to pause the video and draw each of them now. Okay, so you should only be plain if you've drawn the atoms. This is lithium, 2 in the first shell, 1 in the second shell. That's lithium. This is sodium, 2 in the first shell, 8 in the second shell, and 1 in the third shell. This is potassium, 2 in the first shell, 8 in the second shell, 8 in the third shell, and 1 in the fourth shell. What I want you to do now is I want you to pause the video and I want you to write down underneath each one the electronic configuration of each one. Do that now. Okay, so the electronic configuration of lithium is going to be 2, 1. Well done. If you wrote that, sorry, just going to fix that right in a little bit. 2, 1. Electronic configuration of sodium is going to be 2, 8, 1. The electronic configuration of potassium is going to be 2, 8, 8, 1. I'm not sure, but you may have noticed a pattern here. You may have noticed a pattern that all of these elements end in a 1, like this. Now, what does that tell us? Well, if we check the outermost shell, which just means the one that's furthest away from the nucleus, the outermost shell. That's what we call this one, and this one, and this one. This here is what's called the outermost shell. It's also known more correctly as the valence shell. Valence shell. And we're interested in the valence shell because it's the electrons in this shell that are involved in chemical reactions. So these are the electrons involved in chemical reactions. The reason why these are the ones involved in chemical reactions is because they're the ones on the outside of the atom. When atoms react and combine and join together, they react with each other. So obviously, it's the outside of them that's going to come into contact with each other. So basically, it's always the outermost electrons that are involved in chemical reactions. So as you see, all of these elements, lithium, sodium, and potassium, all have 1 valence electron. This is the reason why they have similar properties. This is why they're all highly reactive. Now, this will make a little bit more sense in a couple more lessons when we talk about how the atoms combine. Why are they so reactive? Because they've got 1 electron in their outer shell. We'll delve into that a little bit more, but just know that these are similar to each other because they all have the same amount of valence electrons or electrons in their valence shell. So the first little tip I'm going to tell you about here is a clue in the table, tip. It's worth taking this one down, but wait till I write it first and then you can pause it and take it down. Tip, the group number, so for example, all of these, lithium, sodium, potassium, are in group 1. The group number tells you the number of valence electrons. That's a really important link to make between atoms, the structure of atoms, and the periodic table. Is the group number tells you the number of valence electrons. So for example, these are all in group 1. If I took these elements here, fluorine, chlorine, and bromine, all the elements in this group, this is group 7. They all have 7 valence electrons. Nitrogen, phosphorus, and arsenic, these are all in group 5. They all have 5 valence electrons. We could prove this by drawing them all out and checking, but a shorter way of doing it is to know that it's equal to the group number. Now, the one we have to be careful with is this one. This here is group 0, but it's also sometimes called group 8. And these all have 8 valence electrons. So just be careful. This one doesn't mean they have 0 valence electrons. It's a little bit, sometimes you'll see that written on some periodic tables as group 8, some as group 0. Again, it's just different countries and different scientists like to use a different notation, but know that those have group 8 electrons in their valence shell, except for helium would have 2. But yeah, that's where it gets a little bit complicated. Okay. All right, so take that tip down that's in green there. The group number tells you the number of valence electrons. Pause the video, take that down. And now you're ready to do some questions. So I've got some questions for you. I want you to pause the video and do questions 1 to 6 now, please. Okay, so you should only be watching the video now if you have done questions 1 to 6. So here comes the answers. So how many electrons can the first shell of electrons hold? Well, the first shell can always hold 2. So the answer there is 2. Well done if you said that. First shell can hold 2 electrons. Remember, I'm only going to write down the key thing you should have in your answer, but you should be writing your answer in full sentences. That gives you an opportunity to link information. It gives you an opportunity to practice your scientific writing. And again, all these things help you remember things better. How many electrons can the second, third, and fourth shells of electrons hold? The second, third, and fourth shells can all hold 8 electrons. So you should have said 8. If you said 8, well done. Correct it or fix it. What can the group in the periodic table tell you about the electrons? So what can the group tell you? It tells you the number of valence electrons. Number of valence electrons. Okay, so how many electrons are in the outer shell of the valence shell? So group 1 has 1 valence electron, group 2 has 2, and so on. What groups and period are carbon, lithium, chlorine, and indium in? Okay, so I think I have that written over here. Here you see, carbon is in group 4, lithium is in group 1, chlorine is in group 7, and indium is group 3. Oh, now I've forgotten to write that. It says what groups and period are they in? So I haven't done the period. So this is group period. If you remember what a period is a horizontal row, so like that on the periodic table. Well, carbon would be in period 2, lithium is in period 2, chlorine is in period 3, and indium, I have to check myself, I don't know off by heart, 1, 2, 3, 4, 5. Indium is in period 5. So well done. If you said those, great. What about, what does carbon's group tell you about its structure? So carbon is in group 4. That tells me that carbon has got 4 valence electrons. Very good if you said that. And what does chlorine's group tell you about its structure? Chlorine is in group 7. So it tells me chlorine has got 7 valence electrons. Well done. You said that. Excellent. Right, last little bit. We are going to take a look now at what we call the period. So just a quick reminder of what a period is. Period is a horizontal row on a periodic table. So for example, this is period 1. So this here is period 1. Hydrogen and helium are in period 1. This is period 2, and all of the elements in this horizontal row are in period 2. This here is period 2. This here is period 3. And again, all of the elements in this row are in period 3, and so on. This is 4, this is 5, and this is 6. This is 7. Now, why is this important? Well, the period that an element is in tells you how many shells of electrons they have. So you know the way, if we take a look at lithium, for example, so we're looking over here. lithium has the first shell and the second shell. Now that tells me that lithium has 2 shells. It should be in period 2. Let's go check. Here is lithium, and it's in period 2. It's got 2 shells of electrons. Sodium is in period. It has one here, 2, and 3 shells of electrons. That tells me that sodium should be in period 3. Here is sodium, and here it is in period 3. So you can see the pattern. Potassium has 1, 2, 3, 4 shells of electrons, and here is potassium in period 4. So it's the period number tells you how many shells of electrons they have. So that's tip number 2. So tip number 2, just going to change the color. Tip, and we have tip 1, the group number tells you the number of valence electrons. Tip 2, the period number tells you how many shells or energy levels of electrons you have. Okay, so the period number tells you how many shells of electrons there are. So pause the video, take down tip 2. All right, these are really important tips for helping us to navigate the periodic table in a really quick, shortcut way. So they really are going to help you to quicken your thinking when you're thinking about the structure of atoms. So what we're going to do now is we're going to go up and we're going to practice one more little set of questions. Okay. So you've got 6 questions here. I want you to pause the video and I want you to answer the questions, please. All right, number 1. What can potassium's group and period tell you about its structure? Well, potassium has 1 valence electron. That means it's in group 1. And it has 4 shells or energy levels because it's in period 4. So it has 1 valence electron because it's in group 1. And it has 4 shells because it's in period 4. It's that simple. What about number 2? What can chlorine's group and period tell you about the structure? Well, chlorine's in group 7. That tells me it's got 7 valence electrons. And it's in period 3. That tells me it's got 3 shells of electrons. So it's valence electrons. There are 7 of them, and they are in the 3rd shell. What can xenon's group and period tell you about its structure? Well, xenon is in group 8. It has 8 valence electrons, and it's in period 5. So it's got 5 shells of electrons. Well done, if you said that. A substance is made just of aluminium atoms. What word could you use to describe it? Well, it's only got just aluminium, one type of atom. So what do we call substances like this? We call them elements. So aluminium is an element because it's only made of aluminium atoms. Well done, if you said that. That's from a few lessons ago. Draw an atom of aluminium. This is what you should have here. Correct it. Got it right. 3 valence electrons. Look at your diagram of aluminium. Explain how you would know by looking at it that aluminium is in group 3 and period 3. Well, we know it's in group 3 because it's got 3 valence electrons. There they are. So it's in group 3. And we know it's in period 3 because it's got 1, 2, 3 shells of electrons. So it's got 3 shells. So it's in period 3. It's got 3 valence electrons. So it's in group 3. It's that simple, guys. And there's a new pattern for you. You've added very strongly to your knowledge of the periodic table, the patterns that we can find in there. So just a quick recap. Period number tells us the number of shells of electrons we have. It's in period 1, it's got 1 shell. If it's in period 5, it's got 5 shells, and so on. The group number, the vertical column, that tells you how many valence electrons we have. So all of the elements in group 1, the alkali metals, so these are lithium, sodium, and potassium, all have 1 valence electron. This is why they react and have similar properties. So they react in similar ways and they have similar properties because they've got 1 valence electron. Group 7 elements will all be similar as well. They'll do similar reactions and they have similar properties because they all have 7 valence electrons. That is what makes them similar. That is why they are in the same group. All right, that's the end of today's video. I hope that you found the questions easy enough to follow. If you found the video interesting, you found it easy to understand, you found it easy to follow, you did really good on the questions, please do leave a like on the video and possibly leave a comment. would help the channel, it would help other people to find the videos, it may help other students to learn from the videos. So thank you guys, I'll see you in the next video.